switching. Okay, for time division switching, so instead of using the physical circuit, okay, we switch in time. If you remember, we have the TDM, which is time division multiplexing, and then we have the input and the output, the transmitter and the receiver by moving it like this. Remember this picture? So you have it in the same speed, right? So we move and then we also move, okay, in the same speed. Now if I change this, okay, so that over here doesn't go in a circle like this, but it become like kind of a separate switch that I can select. Okay, which one that I want to touch. So in this case, if I want to send the data from A to C, okay, I will just choose when it touch A, I will just close the switch at C, so that it will send. So please remember this picture, and then we will go to this one, okay. So you have like A, B, C, D here that move like this, and then this is varying the order. So you want to send A to C, okay? So instead of have it moving in the same order, okay? When this receives the data from A, okay, you just close this switch, so it will go to C. And maybe if you want to say B to D, so when it go to here, you just use this switch, okay? So B data will go to D, something like this. So this is called TDM bus switching from the concept of the chapter 7, okay? TDM, the time division multiplexing. The second technique to do the time switching is to use the switching node, okay? To move the data from one slot to another slot. As you can see, we have a TDM frame coming in and a TDM frame coming out of the switching node. So if user 1, okay, this is the data, okay, user 1 want to send the data to user 3. Okay. So user 1, okay, send it into, you have a switching node, right? The switching node, you read this data, put it in a buffer, okay, put it in a buffer. And when it arrives at slot 3, okay, when it goes to slot 3, it will just write the data onto slot 3. You write the data onto slot 3. So it's like sending from user 1 to user 3, like this. So this is done at the switching node. We have some examples here. If you want to put the data from user 4, okay, to user 10, okay. So the incoming TDM frame is like this, okay. So the switching node will read the data from here, put it in a buffer, okay, and then wait until, because this is like coming in and this is like a switching node and this is coming out of the node, right? Remember the picture before? So there is coming in and then coming out, okay? So it will wait until slot number 10, okay? And it will write the data that it keeps onto slot number 10. In this case, the user number 10 will receive the signal from user number 4, right? So this is how you switched in time. Nitipong, please stay with me. How you switch in time, right? Okay, so this is number 4 to number 10, which is okay. Now let's look at another example. If you have, again, input in the time slot number 4, okay? But you want to put in time slot number 2. You want to put it, user 4 want to send to user 2. So what happened? In this case, number 4, when it reads the data into the buffer, number 2 is already gone out. Okay? Number 2 go out already before you get this data. So how do you send from number 4 to number 2, okay? I mean, you send from number 4 to 5, 6, 7, 8, 9, 10, that's okay. But how do you send number 4 to number 3 to 1, okay? So we can do this by recall that each of the frame, okay? Each of the frame contained the slot for all users, right? So this is a slot for user 1, 2, 3, 4, 5. So for user 2 own the slot in every frame, slot number 2 in every frames, okay? So user 1 own the slot in every frame. User 2 own the slot for every frame, okay? So if you got number 4 coming in, and you want to send to number 2, but it's already go out, okay? That's okay. So you wait to the next frame, okay? You wait until the next frame and you put it into the slot number 2 of the next frame. So in this case, you can have a delay of almost 1 frame length, okay? Now let's look at more examples here to really understand what's going on. So this is my 1 frame. Okay, so I have the frame, okay? So if, suppose I have user number 5, okay? 5 want to send to 4. Okay, what do I do? Okay, so I have to I cannot put it in the first frame, right? I read it. Okay, this is frame number 1, TDM frame number 1, frame number 2, frame number 3, like this. Okay, so number 5, I read it. Then I will go to this one, okay? Number 4, right? This is the number 4 of the second frame, okay? Because the number 4 of the first frame has already gone out before number 5 arrived. Okay, then again, when you send, okay, you usually don't send only like 1 byte or very, very short data. You send a long data, right, when you send. So the next one is, again, when you connect, it will become like this. Okay, so it will keep going on like this. You see? So number 5 will send to number 4 continuously, okay, like this. Any questions on this? So you will send, for a long time, okay, not just like 1 byte and finished, okay. So you send, so you just set it. So it will just ship like this. It will just delay. It will delay about, since this is 8 slots, okay, it will delay for 7 slots, right? 1, 2, 3, 4, 5, 6, 7, okay? It will delay for 7 slots, which is almost a frame length. So if your frame is long, suppose your frame is like 50 slots, then it can delay up to 49 slots. That is the most. Okay, and then the next one is will just go, you see that there is no problem because the data will just connect to each other, okay? You can combine the data, okay, to get the whole sequence of data that you want. Now we will look at implementation. Suppose we want a full duplex, okay, at a node, which means that A sent to B, B also sent to A. Okay, think of like a telephone line. Okay, suppose Kanyapat is talking to Ankana. Okay, so you send to Ankana, Ankana send to you. So it's full duplex. Okay, so we want suppose 1 to 7, 7 to 1. Okay, so we want, usually we make connection like that. Okay, we will not, usually it's not one way. Okay, there's two ways communications. So if you have, this is a multiplexer, right? And input lines coming in, you have a TDM frame. Okay, you have a TDM frame. So 0 to 7, so you have 8 time slots. Okay, and then you have time slot interchanger, which is the switch, okay, that we are talking about. But they call interchanger because it's like full duplex. So it's 1 to 7, 7 to 1, something like this. So it's called like interchange. Okay. We can also call this like switching node. Okay. In this time slot interchanger or the switching node, we must have a buffer. Okay, buffer that to keep the data that you read from the slot. Okay, and keep it before put it into the slot coming out. Inside of the switching node or the time slot interchanger, we will have a mapping table. Okay, a mapping table here. And output come out the output frames, which is also 8 slots, okay? And it will go to the demultiplexing, okay? As we have learned in the last chapter. Now, look at the mapping table. Okay, 0 to 4, okay? This is the mapping, this is the input, okay? 0, 1, 2, 4, 5, 6, 7, this is the input, okay? When 0 come in, send to 4. So slot 0, data from slot 0 will go to slot number 4. Slot number 0 will go to slot number 4. This is 0, 1, 2, 3, 4. Okay? Data from slot 0 will go to slot number 4. Data from slot number 4 will go to slot number 0 because it's duplex, full duplex. So data from slot number 4 will go to slot number 0. See? Slot number 4 to slot number 0. Okay, let's look at another pair. Data in slot number 1 will go to slot number 7. So 1 will go to 7. Okay, and 7 will go to 1. 7 will go to slot number 1. Can you see? So from this mapping table, I will get the output frame. So if I change the mapping table, this will be changed, right? And I can also ask you the time delay, right? Because if it's 4 to 5, that's only one slot delay. But if it's 4 to 2, if it's 4 to 2, then you have to count 1, 2, 3, 4, 5, 6, okay, 6 slot delay, something like that. Because you have to put into the next frame. Okay, do you understand this? So this is how we do the full duplex, okay? For the time slot switching, okay? And this is the detail of the mapping. Okay. Okay. What I was talking about is like physical implementation, okay? So that was kind of old. Okay, the basic idea before we have kind of a software. Okay, so right now we kind of writing software. This is called soft switch. Okay, so we kind of code is cheaper. Okay, than the circuit switch because we don't have to build the actual mechanical circuit. Okay, we can build we can kind of write the program and then say that if this one coming in. This user come in and want to go out, you have to switch like this, okay? It's like a function command, something like that, okay? And you can add more functionality into the soft switch, okay? However, we should know, the idea of the basic switch, okay? Because that is like where it comes from. How do you make the switching network possible, okay? As you have done it on the board, and we're gonna do, okay, a group work now. So you have six group, right? We will have assignment. Yeah. We will have assignment. So each group come and get one, please.